Let's talk about Kirchhoff's laws. Kirchhoff actually has two sets of laws. We're going to cover his electrical laws in class right now. We may have a passing encounter with them at the end of the semester when we talk about radiative emissions from atoms and things like that. In the other case, he had three laws, so he's actually quite in line with the usual rule of three laws in physics. In this case, he only has two, and they're actually fairly intuitive laws if you think about it. I can never personally remember which law is the first law and which law is the second law with Kirchhoff. All I remember them as is the loop law and as the junction rule. So I'm going to start off with the junction rule. The junction rule says that if I have some currents coming into a junction and I have some currents leaving the junction, the sum of all the currents in must equal the sum of all the currents out. So in this case, it means that I1, the only current that's in, must equal I2 plus I3. Okay? Fairly straightforward, I hope. This rule is really a rule about conservation of charge. It's saying that I can't have charge, for instance, building up at this junction. If I had I2 was bigger than I1 was bigger than I2 plus I3, I would have charge buildup, and that just isn't allowed. That would very quickly explode, or the charges would go zinging out here super fast to basically compensate for the buildup of charge that doesn't want to be compressed too closely together. So it's pretty intuitive. Now, I should warn you about a few things about applying this rule. One of them is sometimes you're going to have currents coming in, you're going to have currents going out and in, and you're not going to be sure which way the currents go. Maybe you can guess that maybe I1 is in, I2 is out, but then you get I3, I4, I5, and I6 here, and you're not sure which ones of these are going in or out. Don't worry about it. If you don't know which way the currents are going, just label them some random directions. Okay? And then I'm going to go ahead and use Kirchhoff's laws. So the currents in are I1 plus I3 plus, let's see, I5, it looks like. Did I really alternate those? Oh, no, sorry, there's I7. I6 is in. I apologize for that, everybody. And it looks like I2 is out, I4 is out, I5 is out, and I7 is out. Okay? So, in this case, though, it may turn out that maybe I labeled a couple of directions wrong. The way I've written them here, some of them are in, some of them are out, but maybe I7's actually going the other way, and I just didn't know it until I did all the math to find out. It doesn't matter. Do not stress about which way the currents go. If you can make a good educated guess, for instance, the direction the battery is trying to move current, good guess, go for it. But if you don't know, just label it. What's going to happen if I guess wrong? I7 will be negative. Okay? What that's telling me is I just labeled the direction wrong. Again, not a big deal. Do not worry about it. Just let the math tell you that. Okay? All right, that's the junction rule. Next up, I'm going to explain to you the loop law. The two of those combined are going to let us understand pretty much any circuit we want to, at least any of the circuits we're going to look at this semester. Okay, see you in the next video.